Trevor, shut up.
Thank you, Connor.
Okay.
Javon, shut up too.
I'm ready. I've been quiet.
He actually has. Like,
You guys
I've heard him talk.
I know you've done so well. Why ruin it? Okay, so chapter 5 is going to be actually a lot shorter than chapter 4. Chapter 4, we did a lot of the introduction stuff of like, here's the big circle and here's how you use the big circle. So we're still going to be using the big circle. Chapter 5 is, we're going to talk about some more identities. So by the time we're done, we'll have all these guys filled in on this page 3, not today. We're going to be doing some more proofs, finding some more exact values with different formulas. And then we're going to talk about solving trigonometric equations. Okay, so it's just a variety of more trigonometric things, trigonometry. Okay, so you guys should have reciprocal, quotient, Pythagorean, even and odd, but you don't have anything in cofunction. Okay, so there are 6 of these. So we're going to write those down. So sine pi over 2 minus u equals cosine of u. So what these are, well, let's write them down first. No, it's a u. I don't know why we're switching variables, but if you want them like that, put an x. It doesn't matter. I'm just going to tell you what's on the paper, on the blue paper. Oh, I put theta on the blue paper, which, why wouldn't we? Tangent, cotangent. It's kind of a boring set. They're all the same. So, what this does is it gives you a way. Well, I'll show you. I'll wait till you're done. So much writing. Unbelievable. I'll put it back up in just a second. But watch what happens if you graph. If I graph that first one, sine of pi over 2 minus x. Okay, what does that look like? Like, look at what that graph, you know what that graph is. What's that a graph of? It looks like cosine, but the equation that I put in there was the sine of pi over 2 minus x. So each of these graphs, so here's cosine of pi over 2 minus x. Okay, well, get rid of this guy.
I think I genuinely might be stupid.
Why?
Cause I was looking at that so hard trying to figure it out and I couldn't.
It's really just like, so each of those things is just a way to show that you can transform cosine into sine or sine into cosine. It's just a transformation thing. It does come up. So you'll see it come up in proofs. Okay. So when we do proofs, whoops, I lost that. Sorry. When we do proofs, if you see something like this, and we're changing everything to sines and cosines, this mess becomes a sine. Okay, Trevor? This bunch becomes a sine, and so you can take it out and replace it with a sine. So we'll do that tomorrow. I just wanted to have them written down. If you were to go into your book and be like, hey, This is definitely not what we covered in lesson 5.1. I'm cutting a whole bunch out because I think it's some of the stuff that they have is dumb because you cover it again in the next lesson. So we are going to do, the main thing we're going to talk about is factoring. Okay, we're going to talk about factoring trig expressions. So the reason we're doing this is eventually we're going to get to the point where we are solving trig equations, and this is some background knowledge. Okay, so it, in and of itself, it's not useful until we get into solving equations, but this just, like I said, it's just background knowledge. So let me just remind you. Let's say we had x squared plus 3x plus 2. And I asked you to factor that. Okay, I asked you to factor it. What does it factor to? So a reminder, that's why we're doing this. It has to multiply to the end and add up to the middle. Yeah, so it's 1 times 2. So x plus 1, x plus 2. Right? That's factoring. So let's have you try x squared minus 2x minus 8.
Oh shoot, isn't that negative 4? Good job, good job.
Okay, what is it? X minus 4, x plus 2, because that's to multiply to negative 8 and add up to negative 2. Okay, so then what, I know this is a long shot. So what happens when there's a number in front? Okay, I'm just going to review with you. That way you don't have to admit that you don't remember. What you do when you have a number in front, you multiply the a times the c, right? ABC, Pythagorean, or not Pythagorean theorem, quadratic formula. So you multiply a times c is 2, and you now need a number that multiplies to 2 and adds up to 3. So the number always has to add up to the middle one. So what are they? 1 and 2. What that does is it splits this 3 up into a 1 and a 2. So you do 2x squared, let's go 1x plus 2x plus 1. And then you factor each of those pieces. Okay, so what can you pull out of this one? The first 2 there.
Couple of x's.
You can pull an x out, right? They both have an x. That's it, no numbers. Okay, so if you pull an x out, what are you left with here?
2x.
2x plus 1. Okay, yes, you pull a 1 out, and so that you have 2x plus 1. Okay, your goal is that these 2 pieces here need to be the same. So you got to have something in the front. So because you need something in the front, it has to be a 1 there. Okay, now, then you undistribute your 2x plus 1, leaving you with x plus 1 times 2x plus 1. Okay, so let's try 6x squared plus 19x plus 10. Okay, multiply a times c, so it's 60. So you're looking for something that multiplies to 60 and adds to 19. 15 and 4. Okay, 15 and 4. So this middle is, it doesn't matter which order you put them in, it will work out. Okay, 15 and 4 is 19. And then you're factoring each of those two pieces.
Oh, alright, good.
Got it? Got me? We did this before. It's just been a while. What can you pull out of the left-hand bunch of factoring there? 3 and 3 and an x. Okay, leaving you with? Nope, you pulled a 3 out, so what's left? 2. 2x plus 5. Yep, shaking out an x, and you're dividing by 3. This guy, what can you divide? 2. And that leaves you with 2x plus 5, which is what you want, right? Those guys have to be the same. So you know you probably did it right. So then you have your 2x plus 5 and 3x plus 2. Okay, now, this is where life gets a little more interesting. Actually, let's do this one more. One more just because it's going to make your life easier. Okay, how about x squared minus 4? What does it have to add up to? 0.
Oh, and I
I
was
was
multiplied
stupid.
4.
Thank you. X minus 2, x plus 2. You guys, this is, I know you learned this last year with Mr. Anderson and with Mr. Brown. This is something called the difference of squares. I know. Okay, there's something called the difference of squares. It's really handy for when you're factoring. Yeah, that's true. So difference of squares is really handy because it was a bad choice. I should have used 9, but so let's do this. What if it was x squared minus 9? Yeah, because how are the 9 and the 3 related? Square roots, right? So it's just the square root of each piece. Okay? It's a very handy thing to remember because as we get into some more complex factoring, you'll see that. So for example, you can see things like this. Let's say I asked you to factor sine squared plus 5 sine plus 4. Okay, now do not freak out on me. This is a quadratic thing, right? It's a quadratic thing. So we normally have x squared plus 5x plus 4. So can you factor this guy? What would he factor to? X plus 1, x plus 4. So over here, instead of having x's, we have signs. Yes. So this just factors to sine plus 1 and sine plus 4. So it's just like factoring quadratics, except for the fact that your variable, quote unquote variable, is not an x, it's sine. In this case, it's sine. Okay, so let's try tangent squared theta plus tangent theta minus 2. If it helps you to go over here and be like, that's like x squared plus x minus 2, if it helps you to take the tangents out and replace it, factor it, and then use that to give me your final answer. Okay, what does it factor to if it's x's? Well, you guys, this one's easy. What multiplies it 2? 2 and 1, right? Yeah, positive 2, negative 1. Okay, so go back over here and then tell me this would be what? Tangent theta plus 2, tangent theta minus 1. Okay, let's try another one.
I saw the tangent -2 and I thought that's okay.
Right. If it was supposed to be one thing, there would have to be parentheses around it. Okay. So let's go cosine squared minus, that's a minus, sorry, minus 4 cosine minus 12. Okay, so again, if you're like, I hate this, put it into a quadratic. Maybe you'll hate it a little less.
6 and 2, -6.
Okay, so Connor said this is x minus 6, x plus 2, correct? So it's cosine theta minus 6 times cosine theta plus 2. Okay, do you have any questions about that so far? Okay, just like factoring regular, except you're not using x's, you're using cosines, sines, tangents, whatever. Now, so this is why I told you about difference of squares up there, because you might see something like this. Right? That is not a quadratic that we've looked at ever. That's weird. But this is a difference of squares because you have a thing squared minus a thing squared. So difference of squares says that you can do cosine minus sine times cosine plus sine. That's the pattern. That's the factoring pattern for difference of squares. And this is the reason that we learn that pattern, because you could do all of them by going, it multiplies to -4 and it adds up to 0. But you're going to get stuff that's weird like this. Okay, let's try this one. I don't want to spend a ton more time on this. Let's say we've got 6 cotangent squared minus 13 cotangent squared. No, cotangent, sorry, plus 5. Okay, if it was me, I'd be rewriting this 6x squared minus 13x plus 5 until you are comfortable doing it the other way. Okay, this is the thing with the A and the C. So it has to multiply to what? 30 and add up to -13. What are the numbers then?
-15 and 3.
No. Yes. No. Positive 30. Yours multiplies to -30. If you have -15 times 2, that's -30. So there's another option. Yeah, 3 and 10, both negative. So -10, -3, x plus 5. Okay, this is a good one to talk about. Whoops, this x. Okay, what are you gonna take? It's Monday morning. I'm cutting you some slack. It's fine.
You take 2x.
2x out. And that leaves you with what?
3x minus 5.
Correct. Now, I cannot leave this because this is currently 3x plus 5. It's -3x plus 5. So what do we have to take out?
-1.
-1. Yep. And that gives you 3x minus 5. Okay, so then you have 3x minus 5 and 2x minus 1. And then you can go back and write it as cotangent. So it would be 3 cotangent minus 5 times 2 cotangent minus 1.
Giovanna, where's Grayson?
So we could get his nationals weightlifting.
Oh, it very well could be. You want to go back?
Trevor didn't even say anything, to be honest. Trevor's just sitting there minding his own business.
Trevor really was whispering stuff over here.
Okay. This is where it gets a little bit weird.
I want to hear from you. We gotta have.
I mean, it's weird enough as it is. This gets a little bit weirder. Okay. What's the problem?
They're different variables.
Yeah. Hey, save it for later. These are different things. I have a cosecant and a cotangent. Okay, so these guys have to match. And the only thing that we can do is change the one with the square. We cannot really change the cotangent. Oh, it's not. Stop it. Okay. You can only change the one with the square, but the good news is you have something in your possession that deals with cosecant squared. And I'm pretty sure it has to be also cotangent in there with it. Okay, so we know from our paper that the little dog says 1 plus cotangent squared is equal to cosecant squared. So if I really want everything to be in terms of cotangent, which I do, then I take out my cosecant and I replace it with 1 plus cotangent. Okay, so this is 1 plus cotangent squared minus cotangent minus 3. Then I simplify him and then I can factor him. So cotangent squared minus cotangent minus 2. So that is x squared minus x minus 2, which I think we already factored, but for a different one. Yep, x minus 2, x plus 1. So cotangent minus 2, cotangent plus 1. Okay, so listen, if it is not matching, you got to switch them out, and it will be a dog every time. Okay, I cannot give you one that doesn't work because it won't factor. Like factoring is pretty limited, so it has to be able to work. So just look at my time. So let's say we're not going to do this one all the way. So we have secant squared plus 3 tangent x plus 1. I cannot use secant squared because they have to match. So secant squared needs to turn into what?
Tangent squared plus 1.
Yes, tangent squared plus 1. That's this little dog, in case you're like, wait a second, where are you getting that? It's this little dog, secant squared is tangent squared plus 1, or 1 plus tangent squared. So get rid of this and replace him with 1 plus tangent squared. And then you simplify him. So tangent squared plus 3 tangent squared plus 2. And then you can factor him because he's all tangents. I believe we already did this one too. Yeah, so tangent x plus 2, tangent x plus 1. Okay, now that's the only new thing I have to teach you. I want to remind you, we did this on our test, so it's not like it's anything new. You're going to have questions like this. If tangent of, I don't know why I made the parentheses, sorry. If tangent theta equals 3 over negative 4, and sine of theta is less than 0, find cosine theta. Okay, what do?
You find the quadrant it's in?
Okay, I'm going to find the quadrant. So I've got a negative sine and a negative tangent. So what quadrant?
I don't know if we will.
Is it 4?
It's on the right.
Yep, it's quadrant 4. So our cosine in that quadrant is positive. And then what are you going to do? You got to make a triangle. Yep. Okay, so tangent. In one of the classes, I don't remember what class in which test it was, but it was the test. But like you got to label your angle. Otherwise, when you go to pick sine and cosine, you'll be using the wrong angle. So make sure you label your angle. Tangent is opposite over adjacent. What's the hypotenuse? 5. And then you can find the cosine. Cosine is positive, and it will be adjacent over hypotenuse. Okay, so that's on this test because we will use this whole chapter. Not, I said this test, this homework. It's on this homework. It's also on this test. Okay, small homework assignment. 6 questions, which is good. It's a good day.
Choose kindness. Tell them that his friends talking.
Kindness takes way too much work.
Maybe people would listen to you better.
They get the same point across to success.
Yeah. No.
Tell them, no, I don't want to hear from you.
Well,
I
you speaking with me today. I haven't done anything to you.
Yeah.
You know you did.
The biggest thing.
Well, this is the only time I see.
Find her old.
Okay, these ones in the 50s are factoring. If you are Gold Star Club, you may take off number 9. No, you can take off 15, but you got to do those are new and they're weird. So Gold Star Club, 9, 51, 52, 55, 56. You guys, 9 and 15 will take longer than the other ones, just so you know.
Because look, after 6 minutes, I know it.